In the previous video, we talked about parallel lines, and so in this video, we're going to talk about perpendicular lines. So when we have perpendicular lines, that's a big word that we see a lot, and it has a very important meaning and application in geometry. And perpendicular lines, whereas parallel lines never intersect, perpendicular lines do intersect, but they intersect at a 90-degree angle. So when you have perpendicular lines, the symbol for parallel is actually this. The symbol for perpendicular is an upside down T. So you'll see that. Let me erase the parallel symbol. You'll see that quite a bit. That's the symbol for perpendicular. It basically is two lines that intersect at a 90-degree angle. And let me draw a little bit better representation. There we go. So when you see perpendicular lines, they're going to look like this. You're going to have two lines, segments, rays, that intersect, and you're going to have this little box. It means 90 degrees. Remember, this little box always means 90. You've seen this before when we've done right triangles. So if I do a right triangle has a 90-degree angle, which means these two sides are perpendicular. So that's what perpendicular means, intersecting at a 90-degree angle. The special thing about perpendicular is that they have opposite reciprocal slopes. I should say the special slope characteristic. Whereas the parallel lines had the same slope, perpendicular lines have opposite reciprocal slopes. So let's look at perpendicular lines in slope-intercept form, just like we did with the parallel lines. So we've got perpendicular lines in slope-intercept form. Now, slope-intercept form, as we remember, is y equals mx plus b. This is the form that equations will take on so that we can identify the m, which is the slope, and the b, which is the y-intercept. Okay, so how can we use slope-intercept form to help us understand perpendicular lines and identify perpendicular lines? Well, first of all, let's look at this concept of slope. Let's look at this concept of opposite reciprocal. So there's two pieces to this. The first piece is opposite. Now, opposite means if one of them is positive, the other one's got to be negative. Okay, so that's what the opposite piece means. So when two lines are perpendicular, if one's opposite, that means if the one line is positive, the slope for the one line is positive, the slope for the other line is going to be negative. That's a requirement. The other piece is this reciprocal piece. And what that means is if one of the slopes is a over b, the other one has to be b over a. So basically the reciprocal, just like any reciprocal of a fraction, it has to be flipped. So not only do they have to be opposite signs, one positive and one negative, but they have to be reciprocals of each other. They have to be flipped. So let's check this out in the context of slope-intercept form. I'm going to give you a couple of lines here. So let's say I have y equals 2/3 x plus 1. And y equals negative 3/2 x plus 5. Remember, the y-intercepts don't mean anything as far as whether or not the lines are parallel or perpendicular. So all we want to look at is the m. Well, what are the two slopes here? 2/3 and negative 3/2, right? So if these lines are to be perpendicular and intersect at a 90-degree angle, then these slopes have to be opposite reciprocals of each other. So let's check out and see if they are. Let's come over here in the opposite column. The 2/3 is positive. The 3/2 is negative. So does it pass the opposite test? Yes. Let's look for the reciprocal. The 2/3 is 2 over 3. The 3/2 is 3 over 2. So they do pass the reciprocal test. 2 over 3 and 3 over 2 are reciprocals. So to look at them side by side over here, you've got the little box, positive 2 over 3, negative 3 over 2. One's positive, one's negative. One's 2 over 3, one's 3 over 2. So that's opposite reciprocal. Let's take a look at another one. Let's do another pair. So I have y equals 4/5 x, say minus 1, and y equals negative 4/5 x plus 3. Again, if I want to know, are these perpendicular? I'm looking at the slope, the m value, right? So let's check these out. Do they pass the positive negative test? Well, I have a positive 4 over 5, and I have a negative 4 over 5. So do they pass the positive, the opposite test? Yes, they do. Well, I've got a positive 4 over 5 and a negative 4 over 5. Do they pass the reciprocal test? No, they do not. This is 4 over 5, and this is 4 over 5. In order for those two to be reciprocals, this one would have had to have been 5 over 4. So it does not meet the criteria, therefore it is not perpendicular. So that's how you can identify perpendicular lines from equations using slope-intercept form. I want to give you another example, which is a common example that people struggle with, and it's kind of a trick. So we know that they have to be opposites, and we know they have to be reciprocals. Well, what if I gave you these two equations? When I look at these two equations, again, I want to identify the slope, so we identify the m. Well, when I look at this, there's no digit in front of these. What's understood to be there when there's no digit? A 1, right? So this would be negative 1, and that would be positive 1. So let's check out if these pass the test. Let's try the opposite. I've got negative 1, and I've got positive 1. Those are opposites, so that does pass the opposite test. How do I write that as a fraction, though? Well, it's just as simple as putting 1 over 1, right? That's what we do. It's negative 1, that's the same as negative 1 over 1. Remember, when you have a number, you can always put that number over 1. So let's check out the reciprocal test. Well, the first one is negative 1 over 1, and the second one is positive 1 over 1. This does pass the reciprocal test because what do I get when I flip 1 over 1? You get 1 over 1. So when people see this, they tend to think they're not perpendicular. This is a special case where it doesn't look perpendicular based on what you have imagined with fractions, but negative 1 and 1 are opposite reciprocals, as you can see. And that would be as opposed to, what if I gave you y equals 5x minus 2 and y equals negative 5x plus 1? Well, this again is the same number, both positive and negative, but although it passes positive negative, you've got 5 over 1 and you've got negative 5 over 1. They are not reciprocals. The only time it works where you have a positive and negative that's the same number, and they are perpendiculars, when it's negative 1 and positive 1. But otherwise, it's real simple. It's going to be something like you looked for up here, the positive 2 over 3 and the negative 3 over 2. So that's how you determine perpendicular. So if I want to go a step further here, and I want to look at using the slope formula. So what if I give you two lines? I'm going to give you line JK, give you the line symbol, and I'm going to say JK passes through J, let's say that's negative 1, 2, and K, which is at let's say 4, 3. Okay? So we've got JK. And we've got MN, because I'm being real original here, passes through M and N. So we're looking at 1, 0. And I want to know, are these two lines perpendicular? Okay, that's the big question. Are these guys perpendicular? Well, I'm going to erase some of this up here just for your space purposes, and we're going to calculate it out. Now, if you remember, the slope formula is y2 minus y1 over x2 minus x1. So I've been given coordinates. Remember we talked about this with parallel lines. I'm given coordinates now, and so I need to find the slopes of these lines to determine if they are indeed parallel or perpendicular or neither. So let's find the slope of JK. So JK, and normally we would indicate this as MJK, but just to make it easier for you, the slope of JK. Well, remember you rewrite the formula and then you plug in the coordinates. So y2 is 3, y1 is 2, so I have 3 minus 2 on top. X2 is 4, x1 is negative 1, so I have 4 minus negative 1 on the bottom. And we'll come back to that. So now let's look at MN. And we're going to find the slope of MN. And again, rewrite your formula except for the plugins. I have 0 minus 5 on the top. And I have 1 minus 0 on the bottom. So let's solve this sucker out now. 3 minus 2 is 1. 4 minus a negative changes to positive is 1/5. So the slope of JK is 1/5. For MN, on the top, 0 minus 5 is negative 5. 1 minus 0 is 1. And if you look at this carefully, let's do the positive and negative and reciprocal. I've got 1/5 and negative 5 over 1. So I have a positive and a negative, correct? And 5 over 1 is indeed the reciprocal of 1 over 5. So it passes the reciprocal test. So the answer is yes, these guys are perpendicular because JK and MN have opposite reciprocal slopes. JK is positive 1 over 5. MN is negative 5 over 1. If you're on the graph, you would do the same thing that you always do with graphs. You slope, you count the numbers, and you could do that. Or if you're on the graph, you could also, if you get two lines drawn on a graph, you can actually pick 2 points on each line and do the same thing here. Find the slopes and compare. Sometimes lines look perpendicular on a graph, especially in your calculator screen, but that doesn't always mean they're perpendicular, so you got to be careful. So anyway, that is perpendicular lines. One quick note, we'll do the same thing that we did with parallel lines, and we'll play the Google game, and we'll look at what perpendicular lines look like in real life, as you guys would say, at practical applications. So when I look at perpendicular lines, you'll see some familiar pictures. If you look at the power line here, this line here and this vertical line make perpendicular lines. So that's something where you would see perpendicular lines in nature, or not necessarily nature, but just in architecture and everyday objects. If you look at train tracks, it's kind of hard to see here. The actual rails and the ties, the wooden ties that go across the rails, are perpendicular. So that's perpendicular. You see the railroad crossing here, the crossbucks? Those could be perpendicular, not a guarantee. Here's a perpendicular for sure. Here are the parking lot lines for parking. The main stripe that separates the two rows and the lines that separate each space are perpendicular. So you can see that. There's the weather vane that's perpendicular. Again, here's the railroad example. You got the rail and the wooden ties that they actually make perpendicular lines. Okay, here's the vertical and the arm for at the crossbucks at the railroad crossing. Here's windows. See perpendicular lines in the beams that go through windows. Not necessarily go through windows, but those are just structural and decorative. If you look at baseball field, the distance between home and third, the distance between home and first, those are perpendicular lines. You can look at these bricks. The vertical seam of the brick and the horizontal seam of the brick are perpendicular. So there's perpendicularity everywhere, and it is a very important property. But those are just some practical examples that you can use for perpendicular.